In this lecture, I'm going to talk about the merge sort algorithm. We've looked at bubble sort and selection sort. Merge sort is the first of the divide and conquer algorithms we'll be dealing with. So, in merge sort, you need two operations. The first is dividing the list into smaller and smaller, easily sortable chunks. And then the second operation is merging these smaller chunks back into a longer list. So let's do a simple example. So let's take this. We want to sort 5, 3, 2, 4, 1. 1, 2, 3, 4, 5. We know the answer. And the first thing we do is we break it down into little chunks. So we take the first two, and that's our chunk. We take the next two, that's our chunk. And the last one, because it's odd, we can't perfectly divide into two, so we have one by itself. And then we sort them. What's bigger, 5 or 3? 3, so we switch their order. What's bigger, 2 or 4? 2, to stay as they are, and 1 is by itself. So we have our original list, and then we split. Now the split is conceptual. It's very easy just to break it down into its two parts, but it's nice to represent it like this, such that you start with the long list, break it down again, sort it, and then build it back up. So we break it down to all its individual 5 components, and now we merge it back together. So 5, 3 becomes 3, 5. 2, 4 stays as it is. 1 stays as it is. Then I'm going to merge together 3, 5 and 2, 4. Yeah. 2 goes to the front. 3 goes there. 4 goes there. And 5 goes there. And we'll talk about how that is algorithmically in a second. And 1 is still by itself. And lastly, we merge the two lists together. 1 goes to the front. This list is already sorted, so it just pops there. So the algorithm itself, what's happening on step by step? So when we have two lists, we need two counters. We have a counter here for list A, and we have a counter here for list B, the left list and the right list. Okay, and what we have to do is we have to work our way along and compare the two lists. So our first thing is compare AI to BI, or A0 to B0. Compare 3 and 1. Whichever is bigger gets mapped to start a new list C. So now you have 3 lists. A, which are left list, B, which is our right list, and C, which is the list sorted list. Then we do it again. Because 1 is already gone, we move down our list to the next one, which is 2. And we compare 2 and 3. Or AI and BJ are A0 because we haven't moved forward, but B1, which is 3, is 3 greater than 2? No. So 2 now goes in here, and we take a step along in the new list. And now we've stepped along, so we have J is equal to 2, I is equal to 0. And now we ask, is A0 less than B2? It is. So the number 3 gets put in there. And we move along in the list on the left. We do the exact same thing as we have J is equal to 2, I is equal to 1, A1 is less than B, so 5. So this goes here, and there's nothing left on this list, so we just throw it to the end. And that's it. We have our sorted list, step by step. So we have two lists which are sorted, and we say, is the first bigger than the first? Put it there. Second, first, put it there, and so forth and so forth. Now, to do this, it's quite a bit of pseudocode. What you have to do is you take in your array, you have a left index and a right index and a middle. And so that's what splits the array into left side and right side. Yeah, left copy and right copy. Both of them start at 0, and we start sorting. Yeah, so while left index is less than length, so as long as we haven't counted past the end of the array, we keep going. Yeah, and so it keeps on checking. Is that bigger than that? If not, put it into new array, put it into new array, put it into new array. Keep sorting them and sorting them and sorting them. So that's these if statements. One way elements from the left list go, the other way the element from the right list go. And each time we're doing the counter, +1, +1, +1. Here, we count along the left side because the left side is smaller, so that's already gone. Here, the right side is smaller, so we +1 there. And then every single time we move along the sorted list. So we have 3 lists: left list, right list, sorted list. And then this little stuff here is at the very, very end. If you've reached the end of one of the lists, then grab all the other ones from the other list and put it to the end. So that's a bit of work. So how do we do it for letters or words? Sorting, for example. We split it into 2. We split them into elements, and then we sort. So SO, which is bigger? S, so we switch. RT stays as it is, IN stays as it is, G stays as it is. We merge them. So we merge the left side and the right side here. So here we check. Okay, is O less than OR? Yes, go there. Then we move along. Is S less than OR? No, so OR goes there, S goes there, T goes there. And here we have I goes here, G goes there, and N goes there. So then now our left list and our right list are both sorted. And so from that, we can ask, is I less than O? Yes. Is G less than O? Yes. Is N less than O? Yes. And because that's all worked out, we then can just take the list on the left and put it in the next part. Yeah. And that's what those 2 little while loops are all about at the end. So how fast is this to sort? Because merge sort divides it into n into 2. So then we have 2 lists of n divided by 2 length. Then we divide it again, then we divide it again, we divide it again, we divide it again. So every time we're dividing the list into 2. So if you have a list of 16, that means that we have 2 lists of 8, 2 lists of 4, 4 lists of 4, 8 lists of 2, 16 lists of 1. Yeah. And that's how you think about how you do. So each of these are operation. So we have Cn, 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 Cn. How many of them? It's Cn plus Pn all the way up. How many splits do we have? It's log n. Yeah. So here is our first example of the n log n, which is much faster than n squared. So this is a better algorithm than both the bubble sort and the selection sort. So our pseudocode, we've gone through the merge sort pseudocode, but actually the funny thing is about the merge sort, the merge part of the code, but merge sort is funny because it calls self within self, because you're always using the merging again and again and again. So we have a condition if left is greater than right, so that means that you've sorted it, return. But if it's not, you split the list and you send one list to merge sort, the left list, and you send the right list in, and then you go back into it. And so this is very recursive and can be kind of odd the first time you see it. So the flowchart for this is very straightforward because you could either make it very complicated or straightforward. We take our list, we pivot, which means we split our list. We have 2 lists. If the left index and right index overlap, so that means the left side's gone past the right side, it's sorted, or we go through the loop. And here is each split of these. So the amount of times we go around here is log n. And within each sorting, each of them is n. And so that's how we work our way through. So that's our merge sort algorithm, which is the first sort of divide and conquer. The next algorithm we'll look at is a quick sort.